Okay, suppose that I want to simplify the square root of 72. I have made a list of all of my perfect squares from 2 squared, which is 4, to 11 squared, which is 121, over here on the left. The reason I want to do this is actually two reasons. First reason is 72 is not on this list. I go from 64 to 81. So 72 is not a perfect square. The next thing that I want to think about is what is the largest factor of 72 that is a perfect square. And that's going to be the quickest, easiest way to get this radical simplified. So since 72 is not on the list, I start looking at numbers that are less than 72. 64 does not divide 72. 49 doesn't, but 36 does. So I can rewrite 72 as the square root of 36 times 2. The reason I chose 36 is because it is the largest perfect square that divides 72. I know 9 does, I know 4 does. I want the largest perfect square that divides 72. And now I can use the fact that I can write this as the square root of 36 times the square root of 2. And I know what the square root of 36 is. Here's my list. The square root of 36 is going to be 6 because 6 squared is 36. So 6 times the square root of 2. And I have, in fact, simplified this radical. Now, what if instead of choosing 72, what if 72 being 36 times 2, what if I had said 9 times 8? Right? What if I'd done that? Which is also true, right? And 9 is a perfect square. I could write that as the square root of 9 times the square root of 8, and the square root of 9 is 3 times the square root of 8. But now I've got a problem, because 8, while it's not a perfect square, it does have a perfect square factor of 4. And so I would have to simplify again, right? 8 is 4 times 2, so 3 times the square root of 4 times the square root of 2, 3 times 2 times the square root of 2, and I know that 3 times 2 is 6, 6 times the square root of 2. And get the same answer, but it took me a lot more work than if I had used the largest perfect square factor of 72, which is 36. Gets me there in one step instead of a bunch of steps.